we said that this is a very important picture here in which you see the graph of the exponential function and the graph of the logarithmic function, which is the inverse function. Here, if b is greater than 1, and here, if b is between 0 and 1. We studied the transformations of the logarithmic function, okay? And today, we will talk about objective number 7, I believe, which is about the domain of the logarithmic function. Objective number 6, find the domain of the logarithmic function. We said before that since the logarithmic function is the inverse of the exponential function, so the domain of the logarithmic function is in fact the range of the exponential function. And if you remember, the range of the exponential function is from 0 to infinity. So the domain of the logarithmic function would be also from 0 to infinity. So the domain of logarithmic functions is the set of all positive real numbers. So x has to be greater than 0. And we said if you try to find log 0 to the base 2 or log negative 8 to the base 2, the calculator will say to you math error because they are not defined, because 0 and negative 8 are not positive numbers. So the number inside the log, who will x, should be greater than 0. So if you have g of x here, the g of x should be greater than 0. For example, what is the domain of this function? What is inside the log, which is x plus 3, should be positive. So x plus 3 should be positive, greater than 0. If you take 3 to the other side, then x would be greater than negative 3. And if x is greater than negative 3, it means it's from negative 3 to infinity. So the domain is from negative 3 to infinity and negative 3 open, because the vertical asymptote has the equation x equals negative 3. So in fact, if you put x plus 3 equals to 0, you will get the equation of the vertical asymptote immediately. So the equation of the vertical asymptote would be x equals to negative 3, and the graph of the logarithmic function is to the right of the vertical asymptote. So the domain is from negative 3 to infinity. For example, how to find the domain of log x minus 5 to the base 4, x minus 5, which is inside the log, should be greater than 0. It cannot be equal. So x is greater than 5. So if this is the number line, and this is negative infinity, and this is infinity, and this is 5, so x should be greater than 5. So it should be here. So the domain would be from 5 open to infinity open. What about the domain of this function, log? So 2 minus x, which is inside the log, should be greater than 0. So negative x is greater than, if you take 2 to the other side, and then if you multiply by negative 1 or divide by negative 1, you have to change the direction of the inequality. So x would be less than 2. So if this is 2, the graph is here. And this is negative infinity, and this is infinity. So the domain would be from negative infinity up to 2 open, because 2 is not included. So this is about the domain. If we want to solve exercises, مثلا 77, 79 here. Okay, they appear in another slide here. You can see here, yeah. Find the domain of each of the logarithmic functions. So you can solve 77, 79. Log 2 minus x, you put 2 minus x greater than 0 and you solve it. But here in 79, we have a special thing. In 79, we need to find ln x minus 2 square. Okay, the domain of ln x minus 2 to the power 2. So I will write it f of x equals ln x minus 2 square. Now, we know that any logarithmic function, ln is one of the logarithmic functions. We will talk about it now in a second. So this is a logarithmic function. So what is inside the logarithmic function, which is x minus 2 square? This square is a power of x minus 2. It is not a power of the ln. So all of this is inside the ln. So x minus 2 to the power 2 should be greater than 0. But we know that anything to the power 2 is always positive. So in fact, this inequality is always true. This is always true or correct, except at x equals 2. Because if you put x2, this would be 0, and 0 is not greater than 0. So the domain of this function would be all real numbers except 2. You can write it as interval notation from negative infinity to 2, union from 2 to infinity, because you need all the real numbers from negative infinity to infinity except 2. 2 is not included. So from negative infinity to 2, union 2 to infinity. If you put in the calculator, if you replace x by any number, it will evaluate, because 2, the power 2, makes x minus 2 positive. Okay, so pay attention to this question. Let us use common logarithms. There are logarithms in which we call them common logarithms. Okay, common logarithms means base 10. Base 10. So if we have log x to the base 10, this is called common logarithm. And we write it log x. So we don't write the base if the base is 10. So here in this example, modeling height of children, we have log x plus 1. Where is the base? The base is not written. If it is not written, then it is 10. Okay, so the percentage of adult height attained by a boy who is x years old. Okay, so x, this is the number of years. Okay, how old is the boy? Number of years can be modeled by f of x. So this function, which is a logarithmic function, models the percentage of adult height attained. So percentage of adult height attained, this is the function f of x. X years, this is the x, number of years. So x represents boy's age, number of years, from 5 to 15. So this function models boys from 5 to 15. And f of x for girls, there is another function. Okay, another logarithmic function. And f of x represents the percentage of his adult height. Okay, and his adult height means when he reaches 18, you know, when you become an adult, your height will not change after that. Okay, so when you at age 5, what is your height now? Okay, as a percentage of your adult height. Okay, so you can find this using this function. What percentage of his adult height has a boy attained at age 8? Yani if your age is 8, what did you attain? What percentage of your adult height did you attain? You replace x by 8, you put x 8, and you find f of 8. The f of 8 by calculator is approximately 76. So when you are 8 years old, you attained 76% of your adult height. يعني it remains it remains 24% of your adult height. باقي لك 24% of your adult height. You can also answer the checkpoint about this exercise. So let us solve this exercise. The same question. The percentage of adult height attained by a boy who is X years old, same question exactly, can be modeled by this function, okay, this logarithmic function, where X represents the boy's age. Okay, here he did not mention from where to where. F of X represents the percentage of his adult height. Approximately what percentage of his adult height? يعني what is F of attained at age 10? يعني find f of 10, and the answer would be 80% of your adult height. Another exercise, again, the percentage of adult height, and this is for the girls. For the girls, this is the function. This is the logarithmic function. And here, what percentage of her adult height has a girl attained at age 13? So find f of 13, and the answer is 95.4%. So 95.4% of the girls' adult height will be attained at age of 13. يعني خلاص باقي still 5% to go, not more than that. So what are the properties of the common logarithms? We said common logarithms if the base is 10. So we write log will base is 10. Because we studied these properties, we studied them before. We said log 1 for any base is 0. So log 1 for base 10 would be also 0. Log b is 1. So log 10 would be 1 because the base is 10. So log 10, 10, or log 10 is 1. Here, if you replace b by 10, you get log 10 to the power x equals x, and the base is 10, but we don't write it. And here, if you replace b by 10, because the base is 10, you get 10 to the power log x to the base 10, but we don't write it. So 10 log x would be x. So please pay attention to these properties. So for example, this property, log 10 to the power x is x, which is number 3. Okay, we can use it to evaluate log 100, for example. If you write 100 10 to the power 2, then log 10 2 would be 2, because log 10x is x. 1000 can be written as 10 to the power 3, so log 10 3 would be 3. Log 10 to the power 7.1 would be 7.1 using property number 3. Okay, here we solved a question similar to this one. Okay, find the domain again. So the domain of this function, we put 3 minus x greater than 0, and we solve it. So we get x less than 3, and the domain would be from negative infinity to 3. If you have x minus 3 to the power 2, then this is always true, okay, except at 3. So the domain would be all real numbers except 3, or from negative infinity to 3, union from 3 to infinity. For the natural logarithms, so we have common logarithms and natural logarithms, two important types. طبعا for common logarithms, you have a button in the calculator for log. For this button in the calculator with log, the base is 10. And there is another button with ln, okay? Or I will call it len. I will call it len. It is ln, okay? So if the base is e, okay? If the base is e, the number e, then we call it lnx or ln x. Okay, log 1 b 0, if you put b e, you write it ln, and then ln1 is 0. If you change b to e, then ln e is 1, and this is very important. Ln e is 1. We will use ln and e a lot. And here, if you replace b by e, then ln ex is x, and this is very important. And e to the power ln x is also x. So e and ln cancels each other. In fact, you can say that طبعا e to the power x is an exponential function. E is a number greater than 1. So this is the graph of e to the power x, the exponential function. Now, what about the inverse function? The inverse function of this function is this function, which is y equals log x to the base e, but log x to the base b is ln x. So this is the graph of ln x, and this is the graph of e to the power x, and this is the most important exponential function, and this is the most important logarithmic function. Here, for example, ln e2 cancel, ln and e cancel each other because they are inverses of each other, and you get 2. Here, ln e cancels each other, and you get 7x squared. Here, e ln cancels, and you get 2. E ln cancels, and you get 7x squared. This is very important. Let us find the domain of ln 4 minus x. We solved questions like this. We said you put 4 minus x greater than 0, and you continue, and you will find the domain from negative infinity to 4. How to find the domain of this function? You put x plus 2 greater than 0, and you solve this inequality, and you will find that the domain is from negative 2 to infinity. This function models the temperature increase. Okay, so f of x is the increase in the temperature in an enclosed vehicle, okay, after x minutes, when the outside air temperature is between 72 Fahrenheit and 96 Fahrenheit. So x is the number of minutes, okay, and f of x, the increase or the temperature increase in an enclosed vehicle. Use the function to find the temperature increase. So he's asking about the temperature increase, means he is asking about f of x to the nearest degree. So you need to approximate your answer to the nearest degree after 30 minutes. طبعا هنا x minutes, so x number of minutes. We need to find f of 30 because the number of minutes is 30. And if he said here after half an hour, for example, then you cannot replace x by half. You have to change it to minutes, because in the question he said after x minutes. So we need it in minutes. So f of 30 is 13.4 times ln, and you replace x by 30 minus 11.6. You find the answer using the calculator, and you will find that the answer approximately, if you approximate it to the nearest degree, is 34. So the increase in the temperature after 30 minutes would be 34 degrees. This one, the function f of x, again, models wives' weekly housework hours. So how many hours the wives work? So f of x, wives' weekly house hours work, x years, x number of years after 1964. So x number of years after 1964. Use the function to find the number of weekly housework hours. So this is f of x, okay, for wives in 2010. So what should you do? To find x, you subtract 2010 minus 1964, because he said x years after 1964. If you use the calculator, the answer is 46. So he needs f of 46. So you replace x by 46 in the equation. So you write negative 35.2 ln, and you replace x by 46 plus 34.5. You will find that the answer is 21 hours. Round to the nearest hour. So maybe the answer is not 21, maybe it's 20.8, something like this. Then you round it to the nearest hour, you make it 21 hours. Okay, let us solve some exercises. 83. Evaluate or simplify each expression. If you evaluate 83, log 10.7. If you look to the properties, this is immediately equal to 7. 89. E cancels ln, and the answer is 7x squared, 98, sorry. 89, he needs 89. 89 also ln cancels E, and the answer is 6. 91, 95. 91 here, and this is important. Well, what did we study? Okay, there is a property to use, لكن I don't know whether we took it or not. I don't think we took it. So يعني in fact there is a property you are going to study, إنه ln u over v is ln u minus ln v. We are going to study this in the next section, okay? But we don't have it. So we have to solve this question without using this property. So let me do it here. So it is ln 1 over e to the power 6. يعني if you use this property, the answer would be ln 1 minus ln e to the power 6. ولn 1 is 0, فالanswer would be negative 6. لكن how to find it without using this property? You have to write 1 over e to the power 6 like this. You have to take e to the power 6 up. So if you take e to the power 6 from the denominator to the numerator, it would be e to the power negative 6. And now you can cancel ln with e, and the answer would be negative 6. So this is the point here, and you should know that 1 over e to the power 6 is in fact e to the power negative 6. طيب 91, 95, 99, 95, easy. The answer is 9x, okay, because ln cancels e. 99 also log 10 cancels 10, and the answer is square root of x. All of these are examples about the properties. طيب here, what should we do here? Question 109. This is a nice question because I think this is from Practice Plus. Find the domain. This would be the last question we solved today. Find the domain of each logarithmic function. Yeah, this is the last question here. So we need to find the domain of f of x equals ln x squared minus x minus 2. As we said, the domain would be anything inside the ln, which is x squared minus x minus 2, should be greater than 0. But the question, how to solve this inequality? This inequality is not a linear inequality. We have degree 2. So this is a degree 2 inequality or quadratic inequality. We solve quadratic inequalities by finding the zeros of the left-hand side. And to find the zeros of the left-hand side, you need to factor it. So x squared, you can write it x times x, and you can search for two numbers. Their product is negative 2, and their sum is negative 1. So you have negative 2 and plus 1. Now x times x is x squared, negative 2x plus x is negative x, and negative 2 times 1 is negative 2. So now the zeros of the left-hand side are 2 and negative 1. You put these zeros here. on the number line. So here -1 because it's smaller, or here 2. And then you put here x minus, you can put x squared minus x minus 2, all of it, no problem. Okay, you can put all of it. طبعا -1 is not included, with 2 is not included, لأنه greater than, not greater than or equal. Choose a number, for example, between -1 and 2. Choose 0. Okay, if you replace x by 0, you will get -2. So here, the sign of x squared minus x minus 2 is negative. If you take a number greater than 2 and replace x by 3, for example, you will find it positive. If you take -2 or -3, a number between -infinity and -1, and replace x by that number, -2 squared, for example, minus -2, you will find it positive. We need this quantity, x squared minus x minus 2, we need it to be greater than 0, yani positive. So this is the solution, and this is the solution. So the domain of this inequality would be from -infinity to -1, union from 2 to infinity. By this, I come to the end of section 4.2, and please ask any question, and I'll be glad